We're on. Who wants to be the focus of the camera today?
Camera loves it.
Yeah.
It's okay, I'm on there too.
Good background too.
Yeah, get some math in the background, some addition, it looks like. Multiplication.
Yeah, I didn't want to compute the cube root of the square root of 2. I didn't have my calculator, so I just said, I think that's what it is.
Well, good afternoon. How's the last week been? 2 weeks been for everyone? Teaching related or not?
First exams are done.
Yeah.
Oh, yeah, that.
So who was grading 165 and 166 have both been done and graded now? Because 165 was just this last week.
Yeah.
So I'm betting all of you guys were grading. How did that go?
Shocking. I mean, I haven't.
Shockingly poor.
Yeah.
What did you grade?
Yeah, what
Calc 1.
what problem?
Question 5. I don't know if you
What
know.
was that one about?
I mean, this was a problem that they've seen before in their quizzes, where it's just like, you're given a tangent line to a function, so it has encoded some information about a point and a slope, and you have to apply that to another function, which is a composition of two functions. And, I mean, that one they did, well relatively compared to all the other questions. But I importing their scores this morning, it was a little bit of a shock. Even for Steve, he sent out an email about being cautious about approaching the students with their, with their effort.
Wasn't the median? I mean, I didn't actually click on the picture, but it looked like it was like 20 out of 60 or something.
26 or something was the median.
Mm-hmm. That was the cutoff for a B, 26 out of 60.
Oh, wow.
The Calc 2 tests were apparently a little bit above average.
Yeah, they were good.
It was pretty okay. I guess when you put it that way, the median was like more like 30 to 31, but that is different, I guess.
Like, or I'd say above average compared to other years, otherwise that doesn't really mean anything. All students scored above average. I noticed on most of the calc, you could definitely, and I think we talked about this a couple sessions ago, that the results were definitely bimodal. You got a lot of like here and here kind of thing, which definitely has some sort of implications towards like what's going. There's some kind of factor that's creating this bimodal distribution. I'd be curious about what that is, but.
This was Calc 1.
It looked like Calc 1 just came out, right?
Yeah, it looked just very
Yeah, it looked fairly
flat in the center.
Maybe
there wasn't much on the high end or the low end, but it was pretty flat in the
It
center.
kind of looked positive skewed, though.
Yeah, that could very well be a camera exactly.
But Calc 2, I remember looking fairly bimodal.
Yes. Definitely not a normal.
Yeah, not completely distinct, but you definitely have like.
Yes.
Which means there's some kind of factor that's these students are doing well because of this, and these students aren't doing as well.
There it's.
That was 165?
Yeah. Fairly red. Someone got a 60.
Actually,
I thought one
four
person
people
got
did. No.
it for 59.
For
Oh.
Calc,
Thinking
for
you
Calc
got
1, only
60.
one person. The high score is 59, only one person.
Oh, okay.
It's like Calc 2.
Holy moly. Okay, then. Yeah, so very few people got better than 55.
The median was 25.
In
Oh,
fact,
wow.
Steve
The
went
average
through
was
and put a sticker
24.
on everyone who got an A without the curve.
Yeah.
I noticed.
Yeah.
I had one in my collection. fractions sections.
I know it would have been more work for him, but I found it a little annoying that he clearly did do all of the sums in order to justify the stickers.
But then didn't
Didn't
write the
write them
sums.
down.
He didn't write the sum.
He
Yeah.
could have just given us the stickers, and we could have. Anyway.
Well, I guess I'm anticipating he enters them in, he enters them in a row, and then I would assume that would calculate the sum for him, and then he would.
Maybe.
That is just a guess, but maybe not.
Because does he need to report the scores to someone?
He's told us one question.
Yeah.
Well,
So.
he probably has to have some sort of statistic on the effectiveness of this coordinated calculus.
Sure.
And that's probably a gauge.
Can't imagine entering all those scores though.
Right.
Can't either.
Yeah.
I think he has help with that this semester, though. I thought maybe not.
What's people's feelings on stickers, though?
I think it's a cool idea.
Yeah.
Actually, I will
I
say,
like
Spies.
stickers. I like stickers.
as Kate can perhaps attest to, the highlight of Real Analysis 1 was the fact that grader Max Bacharach would put little giraffe stickers that he got on Etsy on our quizzes if we got everything right. And it
We
was
freaked out one time when he didn't put them on. We were like,
Yeah.
we deserve stickers,
'Cause he,
and he had to go buy more.
That's why I despise them.
Well, I think it's like for graduate students, it's fun, but like for undergraduates, sometimes you can get someone with a fragile ego, whether or not they got a sticker.
Yeah, I remember as an undergrad in my math major courses, there were a few TAs that did stickers, and I loved that, right?
Yeah.
But I don't know how I would feel, in just a general calculus class, not as a math major.
Yeah, like-
but I liked it.
Some students, they'll be like, they got a 30 on the first exam, and they'll be enthusiastic because it's above average. But if somebody who got a 30 got a sticker who didn't appreciate that, you have to make a judgment call.
I like the stickers because when I went through my students exam, I was happy to see a sticker.
Yeah, I
Well.
second that.
Ooh, they got a sticker.
Right, somebody did well.
If someone gets a 60, I think they get a scratch and sniff sticker.
That's
Oh, really?
Scratch
one,
and
one of
sniff
my
are great.
students did get one at a 60 on the first exam, and the sticker. And it didn't occur to me to check whether it was scratch and sniff, but it did say number 1 unique with a rainbow on it. So it was a very high quality sticker indeed.
Do we get stickers equal to how many students? In stickers? No.
We should bring this to Steve.
Hmm.
And then stickers for the bottom 5% would be appropriate.
Scratches.
Probably not. Really bad smelling.
Yeah.
Oh no! Stinky stickers. Awful.
You wouldn't know until you scratched it.
Right.
Oh, okay.
You did bad. You got a stinky
You have to scratch it under the
Yeah.
scratch is your
Like,
actual score.
oh, that's where it's at.
We found
So-
a market.
Back to the text.
I just gotta say, when I was in 8th grade, my math teacher, she would give us stars with our names on it.
With
And
your
she-
name on
Yeah,
it?
Wow.
and so for every time you got a perfect on a quiz or an exam, you got to put a star with your name on it up wherever you wanted in the classroom.
Oh.
And so, I claimed the clock as fast as I could. Because everyone would have to look at the clock. You know?
That's a good idea.
Look at least.
But I do wonder, does that really, throw people off if they're not,
Being rewarded.
getting their stars on the clock?
Or even if they are being rewarded, is that necessarily it adds a motivation, but what's a motivation for it? You could talk about intrinsic versus extrinsic values. I don't know if that necessarily comes into play at this
The
stage in their
college
mathematical
level.
career, right?
Yeah.
But
Yes.
Yeah.
The college level, yeah, I do think it's more just lightening the mood a bit, right?
Yeah. Well, and actually, yeah. So last semester doing standalone Calc 2, one time I don't remember giving an exam back everyone in the class was like, well, come on, there should have been some extra credit or something. Or I don't remember what the situation was. The point was raised that if I gave everyone extra credit, then it doesn't really do anything.
If it's
But they,
curved.
but they all just said, yes, we want extra credit. So
Right. Yeah.
I don't think I gave them extra credit. I might have later, based on this feedback.
Just give them 5 points extra credit and decrease the curve by 5. It's fine.
It's like the biggest mistake I ever made teaching was when they ask for extra credit, you give that to them. It's just like, because then they kind of feel like they can push you.
Mm-hmm.
It's like, I never do that again.
I think the only reason why you're doing something is just in response to this thing. I think I don't know. If it's made clear to the students of I'm doing this because this is why it works out best for your learning, maybe like in the future you can then say, okay, we're not going to do this because this is good for your learning. Because that's like a really cheesy discussion that I do have with all my classes, that like I'm doing this, like everything that I'm doing is because I want to make sure that you learn in the best way. And so if you request something and I say, yeah, that's a really good idea, this is something that we should do, I'll do it. Mm-hmm. And then later if they do it, like ask for something else and they don't get it, I'm just going to say, oh, well, this is the reason why I don't think it's best for this. And a lot of times they'll respect that because they know that I'm trying to look out for their learning. I don't know, maybe not. Good definitive answer, right?
Yeah. This is what I'm doing, or not. Maybe I don't know.
I mean, that's kind of like an accurate appraisal of the situation to some extent, though, right? We're trying.
It's something that I feel like works for me. I don't know if it would work in all situations.
I've had good results trying to like be as upfront as possible with college students, at least. I don't know how well it would work at other levels.
I think that ties in sort of nicely, actually, with some of our thoughts from the rating and the idea of like effortful learning. If we look at number 2 here, so it says the authors explain that there's often a fundamental mismatch between the actual benefits and perceived benefits of effortful learning. Why do you think that's the case? How do you help students? That's what I'm going for. How do you help students see the value of effortful learning? So something that they maybe resist because it doesn't seem to be helping them. I could see what Joel said as a strategy, just telling them, right up front, this is, I'm trying to do what's best for you. This is what's shown to be best. This is, I could see that being one strategy, but I didn't know if you guys had any ideas for other strategies and helping students actually see the value of that idea of effortful learning. In addition to, I think just telling them can definitely, that would be sort of my first line of approach, but I don't think that always helps.
It could be taken in a way of, this is what's best for you. I know better than you. As far
That's
as like,
true.
I know better of how you learn. They have to be able to believe that you actually have something to say, right?
Yes.
Which is really hard.
And the buy-in.
I think that especially with like the quiz system, right? You can have a lot of students who can spend a lot of time learning the solutions to the quiz problems and not actually learning what's going on. And like the thing that I would say for a lot of them, because they believe that that's the easier way to learn it, right?
Mm-hmm.
The easier way to learn it is to learn what's going on, and we know that there are other times where that's actually going to be harder. But I feel like it's really just shifting the difficulty to something else. Like understanding something is definitely very difficult, but then once you have that understanding, it makes different parts, like understanding how to work these problems is a lot easier. It takes the stress off of just trying to do these problems and without an understanding, to the stress of learning kind of what's going on, but with the conceptually understanding what's going on with it, which both of those are difficult, but in completely different ways. I think it's too easy to say, oh yeah, it's much easier for you to just learn the concepts and then everything else becomes easy from that. I don't think that that's easier. It's just a different type of difficulty.
Then wouldn't like a better way of evaluating the students would be not to give them quizzes with the same exact questions on them, but an alternative where it's the same sort of methodology that you use to answer the quiz questions.
Mhm.
Then you get away from that easy learning.
To me, it's kind of like though, like in the chapter about they were the jumping, training. They were talking
yes.
about this is very relevant to me. I got to get ready to do this now. Like, there's that motivation there. I've had professors who, they didn't collect homework at all. They said, 3 homework problems will be on the exam. That's why we did the homework. I mean, but and I wonder how they approach the quiz bank. Is it similar to that, where I do the quiz bank ahead of time? I mean, I think, I don't know, they're waiting around a lot for you to do it in recitation. Well, not anymore, so maybe it's different.
For those, I know Nate is in Calc recitations right now. Joel, what's your teacher?
Calc 3.
Calc 3.
Yeah, same here.
Same here. Okay, so Nate, and you have the 143, which is starting later, Kate, right? Today at 4. That's so exciting. You can just bring the book in with you and be like, look at this book. Nate, do you feel like your 165 students are starting to push doing the quiz bank problems earlier because recitation time isn't spent on that, or do you notice a difference at all, or do you have context to compare it to?
Up to this point, it's been about, in my opinion, consistent with the students are not practicing in advance. There's some, I don't know if they're doing it on their own per se, or if one person's doing it and a lot of them are kind of, seeking out that person. Because I see a lot of redundancy and major mistakes, which you shouldn't assume a large portion of the class should be making unless they're copying. So, I don't know, that may change. I try to mention something like that every week, but it has not been effective.
I think we talked about this last time, but it would almost be interesting to have study sessions or whether it's recitations or something where, okay, it's expected that you come having already worked these 10 problems, and then a significant amount of, the 50 minutes or whatever is spent, or even 30 minutes is spent. Okay, what's a common thread between these types of problems? What's a common thread between, and not just, these integrals are set up the same, but no, how does this relate to a picture? How does this relate to, what's the big picture? And having students, one, try to generate that answer, but then also promote that reflection in terms of what they've tried.
Yeah, that kind of sounds like what Steve's trying to get at with these contextual type problems.
Right.
And then something like this study group would kind of hone that idea. But it's like the pushback I get from students is that they're looking for, because it's math, they're looking for something quantitative. Right. They're always after an analytical result. Right. So they don't ever kind of gauge the contextual part.
So it's really interesting. I had a tie-in point that I just got really excited about when I was reading, and this has to do with question 13 here. And it was talking about failure, and it said specifically failure underlies the scientific method. And then I was thinking, well, in math, we typically, at least how materials typically presented, we don't use the scientific method much. It's very much more a prescribed this is how you do this type of problem. Now learn how to do this type of problem. And I was wondering if we departed from that model, or what sort of long-term impacts that has, or why we choose to do math that way, or why we don't do math more in line with scientific model. A lot of people do, right? But that's definitely not the prevailing math mindset. We think, okay, science does its own thing, and math does its own thing there. And yeah, I don't know. So what do you guys think about that?
Well, if we could expose undergraduates to even a hint of the kind of nonsense that grad students even have to go through for their research, then they would quickly realize that it has quite a lot in common with the banging your head against the wall of scientific problems.
Mm-hmm.
But that's kind of, they don't really see that until like senior undergrad math major.
Mm-hmm.
Yeah, because even as an elementary school student, I remember doing those little exercises where you talk about the scientific method and what are the different steps. That was always in the context of a science class, never in the context of a math class. And I just wonder if we'd be more,
So
yeah.
Oh, sorry. I was going to say the difficulty about exposing like the scientific method is that you have so many students coming from various backgrounds, and the first, well, I suppose the second step of the scientific method after observation is to formulate a hypothesis in which they have to have they have to have a level of critical thinking in order to develop an idea along that vein. And with people coming from all sorts of different backgrounds, you see, it'd be hard to put people together in a room and have everyone be able to kind of work cohesively in that regard.
But even on a micro level, like, isn't that what we want students to do when they're solving a problem, though? Or even what they're talking about in the book in terms of, oh, I tried this method. Oh, it didn't work. What did I learn from that? Let's see. My next hypothesis is that this method will work. I'm sort of working through. But I've never had it framed that way to me, specifically scientific method terminology.
I think a lot of it has to do with the things that we teach in our math classes to like general math. Like general students are very much taught as tools that they can use. So like if you're going to learn to use a tool, you're going to learn the specific ways of what this tool is and how it can be used.
Yes.
And I think that's like how math has traditionally been taught. These are some tools that you can use, which doesn't require exploration if you're just using it as tools. Whether that's actually the best way to learn mathematics. And
yes, another question.
Yeah.
Oh, kind of like the introductory physics courses where they have like the equations for basic kinetics and stuff like that. In fact, I've heard them mention this in contrast to the calc or quizzes that they get, is that at least with the physics exams, they just have an equation. You just have to find one, plug it in.
I don't know if students have ever even seen that scientific method modeled in mathematics. And even if you have the syllabus is so packed, there really isn't time to fail when you're presenting.
That was the other thing that I was going to say, is that there's not enough time to do the scientific method in the way that we have our courses structured.
Yeah, it's interesting. Alex Andriotti and I would teach kind of a math seminar for practicing secondary teachers, and one of the things that we would have them read was, what is mathematics? And one of the things that the author noted was this idea of almost a restaurant, in a high-end restaurant, where all the food is prepared and then brought out to you on a platter, and how in much of mathematics, that's how we present the mathematics. Here is this. You need to know this. Whereas, it is very clean, it's very formal, it's very nicely presented. But if you were to go into the kitchen, it could be a mess in there. But that's where they're making the mathematics. And so we don't really have the time to mess around and have students play with it, whether it's a mini RAU project or just even posing a problem that has enough, a high ceiling but low entry level, where students can jump in without having a lot of mathematical background, but then the potential that's wrapped up in that problem is vast, but it's but how do you do that in a calculus 2 setting, or how do you do that in a, these are the standards that have to be met in order for a student to go on to the next course.
Do you think that like taking the time to, like you were saying, model some kind of scientific method, like even towards the beginning of the class, doing it like that's something that I used to do with high school students, is like towards the beginning I would actually do like a small kind of very open-ended type of problem where I just have them explore something that kind of sets up a mode in the classroom that even if we're not doing something specifically, like some specific activity around that, it kind of frames things in such a way that they understand like what I think about how mathematics should work and ways that they can approach different things. I think that the context is maybe what's missing to make it easier to build into something that's not specifically like exploration of math, but also like even you were talking about, we want people to solve, like on a micro level, we want people to solve these problems through kind of a mini scientific method type of way. Need something a frame to actually frame that around. Yeah.
I think they're going to use something, as you said, very low entry level, but also I think unfamiliar,
Yes.
so that they have to explore. The nearest thing I think was that driving Iowa City to Ames to Iowa City project we have, but still people come in already thinking they know how to deal with speed and distance and time, and it's something they think they should know how to do. But
I think that might tie in pretty nicely to the questions 11 and 12, which are talking about failure in particular. These are questions that Marion had written, which I thought was excellent. And I specifically liked number 12, which said, where should failure be taking place? So if failure is an essential part of the learning process, then where do we see that in our structure, and where should that be for students? You guys have any thoughts?
I think a way to answer that would be, what do you expect when you test? So how do you build your test?
And what's the point? What's the goal of your testing? Et cetera, et cetera. But it's hard because you see this a bit of a dichotomy right here that 11 is pointing out. Is we always have this, we say making mistakes is a good thing, right? But you make a mistake on a test and you get a lower score, and that hurts you. That hurts your test. That hurts your GPA. Same thing on scored homework, right? So how do we sort of reconcile those two things? If we're saying errors are good and part of the learning process, then how are we being consistent?
Well, the homework's already dealt with because you get unlimited attempts, so it's like try it, fail it as many times as it takes.
Yes.
But these are points you have to get. I mean, you just should if you try.
Yes.
And I mean, weekly quizzes, I've always, whenever I've taught as a lead instructor too, I've always had weekly quizzes because you gotta fail. You gotta challenge yourself without notes. But I think one thing I do differently on I used to do differently on my weekly quizzes that, we have different in the quiz bank, is my weekly quizzes were never really like exam problems. They were actually homework problems. And I think that's before we coordinated calculus. I think a lot of instructors did that too. They made them like find this derivative or, really just, technical stuff, not conceptual stuff, where they didn't have to put together a lot of steps.
And then even some of the exam problems were also like, it's not like all of them were, but I think that was kind of before coordinating. The exam problems did model the homework a little bit more.
Yeah. And I mean, I agree that it's not sufficient to have an exam. That's just skills. But
I think with the concept of failing, it's important to understand that like failing just for failing's sake isn't good. You want to right? You want to fail and then correct, and that's where the learning takes place.
Yes.
And so, like whenever we're talking about when should this failing be taking place, right? If it's a summative test, right?
Yeah.
Failing there isn't as helpful for their learning because that is their summative idea. If they never get this back again, then they're not going to be able to learn from something with that. While, say, on quizzes or homeworks or different things like that. Hopefully those are structured in such a way that it's more as a formative assessment where if you fail here, then this is a way to see corrections to that. So failing isn't good, but failure with correction attached to it is where the learning takes place.
So maybe there should be like some sort of reward system for correcting your mistakes.
Yeah, that's something
beneficial.
That's something that I did with survey and calculus. I had them for office hours. They could come in and make up points back on any of the quizzes that they took, and it worked out really well. And a lot of students, I feel, use that effectively.
Yeah, I think that'd be worthwhile.
Yeah.
I think that's, I was just wondering, what is the role of failure in your class? We say in our classes, it's okay to fail. That helps you learn. But I don't think we ever, at least, immediately reward students for that.
Right.
The hope is it's a secondary reward that when they take the test, they'll have learned something. But I don't see why really students have an incentive to fail in my classroom because I don't. And the way calculus is structured, there's no way to have them redo an exam question or something like that. On the other hand, I know a lot of students in tests, they're done in 30 minutes and out the door. And so one thing they aren't getting, message they aren't getting, is that if you don't get something right away, think about it. But a lot of students just think there's no way I'm ever going to get this, no matter how much I think about it. Turn in their tests after 20 minutes and they're gone.
One thing that I've done in classes before is that I've had quizzes where the first few problems will be more procedural or just computationally not too intense, and then I'll have a last problem that's more intense, and it will be purely scored off of tried 3 different methods to solve this problem. Not whether they got it or not, but did they give an honest, clear try to 3 different methods. And that's my little way, obviously, that's not an exam or so on, but trying to encourage them that the trying, right? And that maybe as you're going through those 3 ideas, something might catch on that you didn't think would initially, but it's hard in a test setting, especially when
grades are what stands in the way. We should just get rid of grades.
right.
Right?
I mean, MIT in their first year, it's the last semester.
Really? Cool. I like that.
I was also selfishly hoping that we would be able to talk about the reflection piece because I was hoping there would be some good ideas to glean. So number 9 says, reflection is an extremely powerful learning tool as it combines all these different elements, retrieval, elaboration, generation. So I was wondering if there were any specific reflection times, either that you did individually or that you had a teacher, instructor do, high school, college, etc., any type of reflection assignment or exercise that was effective for you or that sticks out in your mind. I hope.
So I think the one that comes to my mind is it was like my first like abstract algebra course, but like we took a quiz, handed it in, and then immediately it was like, okay, you do 1, you do 2, like on the board right now in front of everyone. And there's only 6 of us, so it was pretty low stakes as far as. And then we sat there, and he's like, all right, and our professor was like, okay, now, you know, and he didn't use like names, but like, let's look at number 1. You know, everyone go through, say something that's right and say something that's wrong about this proof. And, you know, it was pretty, like, intense, rapid feedback. And also from, like, your peers of being like, oh, that sentence doesn't have a verb in it, you know, or things like that. And I think that was, I remember being, like, you know, really just kind of not only be able to see, like, corrections on my own work, but then be able to give corrections to other people's work.
Yes.
I remember that kind of being, like, really stuck with me.
I like that because it incorporates the reflection and then the collaborative reflection as well.
Which I think that's helpful because not only are you able to receive feedback, but then also be able to, like, in the future give yourself feedback if you're able to pull apart what you, like, what someone else did wrong.
Yes, 100%.
I feel like in general having any student like to facilitate discussion between students is a great way for students to kind of synthesize information together as well as like review some of the things that they've already known. In my recitations right now, I try and give them like the first 5 to 10 minutes to just talk to each other about the problems that they've been looking at, and then after that we'll start looking at stuff. Also, pausing when looking at examples, or just pausing in the middle of lecture. Like it's such an unnatural thing to do, but is super helpful because you just then have time to sit there and think about what it is. And I feel like it's both unnatural for the instructor and the student because everything's sitting there. But actually, as a student, I don't think there's been a time where I felt like, oh, this is just too long. Even if I'm done thinking about it or I feel like I understand it, then perfectly content there, kind of letting the information stew around. I've stopped and just told everyone, think about this now. They've done nothing.
Well, that totally brings to mind the way Tathagata teaches anything,
Sure.
Which may include sometimes noticing that certain graduate students are getting a little drowsy during the 2 o'clock class and then being like, here's the chalk, you finish this proof. That's not really, I got the drawing right, I didn't put the right labels on it. But I don't know how well that would go over in a non-graduate course setting. But like, he definitely tactically will be like, okay, we're stopping so that everyone can look at this, and then he looks around, and if you're not looking at it, then he'll be like, hey, no, look at this. Which definitely puts people on the spot, but like, if he does it to call out things that are important, so.
Sorry, go ahead.
No, he's just saying he's very bold. It's hard for me to do things like that.
I don't know if anyone else experienced this, but I know that when I was reading the sections, I definitely over and over again have major qual studying flashbacks in terms of being like, okay, when was the last time when I was trying to synthesize a very large amount of material, right? And what types of strategies did I use? What was effective? What wasn't effective, etc. And I know for me, reflecting on problems that I did was very, very important. And when you say reflecting, that was general, but like making an outline in my mind. Okay, like what were the main steps of this problem? What parts of this problem were similar to other problems or different than other problems? What were the key steps used in these problems? And I know for me, I don't know if that's, I wouldn't say it's, claim to say it's universal, but I know for me, that made a huge difference. And it was sort of it was a bit of a reality check for me in the sense of, okay, this is probably sort of how students feel in many cases when they're confronted with a problem that they don't know how to do, right? And how can I encourage them, even in small ways, right? Like students are reviewing for an exam, and how can I help them know how to go through practice tests better, right? why many students are going through practice tests, but maybe what are small things that I can even share from them that might have more input, even if I say, oh, from my own experience, when I go through a problem, X, Y, Z, X, Y, Z. But anyways, I read so much of it, and I just think, oh, qual. Stay away. So I don't know if you guys have any experiences from your own qual studying, perhaps, that you think might be relevant to undergraduates in terms of methods or difficulties or encounters, or maybe all of you guys had an easy time with your qual.
I'd try to encourage my students to group the types of questions. I mean, because that's what I did with a qual group, is we'd pick a topic every week, and then we'd have a group of questions.
Yes.
About that topic.
But the book says that's bad.
Well, identifying, because
Yes.
you're the one who has to
Yeah.
identify the similarities
The
and
compare and
differences.
contrast.
Yeah,
That
I
is
mean,
a very good
We were
exercise.
digging in
yes, for sure.
textbooks and finding questions
Yeah.
about,
Mm.
yeah, because, well, that's interesting you say it's bad, because I wonder, because I've been encouraging them so much, like, know these types of questions. Like, what do you got to do? You got to
Yeah.
set the derivative equal to 0, find the critical points. Like, if they do that, they'll get like 3/5 of the points or whatever. So you just, like, you just know what type of question you're dealing with.
I think that's
You can go a
the
long ways.
key issue
Yeah,
is
yeah.
making sure you understand this is the type of problem and this is how I would approach it.
Mm-hmm.
Because I feel like that is where a lot of students get stuck of. What is the problem even asking? How do I start it?
Yeah.
And that is the question that you're asking right there of, okay, what kind of problems are all kind of working the same way?
Mm-hmm.
And the idea that
Which
you
isn't
learn
the same thing as
to
fashion.
identify those different types of problems by looking at a range, by not looking at just that type of problem, but looking at many of these different types of problems makes you better at that identification process. Which, okay, I know I have a lot to say today, but I just got so excited while I was doing the reading. I don't know, I think there might be other people at this table who have more expertise in this than I do, but it totally reminded me when they were talking about being exposed to varied practice, like different types of problems, then being better at recognizing. That totally reminded me of a neural network and all this image recognition stuff,
Mhm.
and how you feed it all the labeled data, and then it learns to appropriately labeled pictures. But I believe that one of the keys for the neural network is that you don't just feed it pictures of apples, right? You feed it pictures of apples and you feed it pictures of oranges, and then it does a better job at identifying apples than if you had just, fed it pictures of apples. Okay, Joel, thank you. I thought someone here would be sure to know that. But I thought that was really,
Because it needs some kind of
really
reference.
cool. Yeah.
Otherwise, it just thinks any picture that it looks like is an apple.
Yeah.
Yeah.
And even, something like that.
Another technique that helped with qual study is, like, to try to get into thinking about what it takes to write a problem, like the types you're looking at, like all those group homomorphism questions you see, and think about.
Which, I mean, calc students could make these observations about, like, limit problems or anything in chapter 6 or what have you. There's, like, a couple things per section, and reverse engineering our engineering of these problems wouldn't be that impossible, but I don't know.
Right. Actually, that's kind of what I told my students last week in preparation for the exam. I was like, a lot of these questions that Steve writes are about unpacking, because what he does is that he starts with the solution to the problem, and then he works backwards to condense it into something that looks confusing, and you have to unpack it and go the other direction.
You had a good activity with your students about forming problems, right?
Did I?
Yeah.
What did I do?
Your derivative box or integral box?
That's cool.
No.
Oh, tell me about this.
Yeah, it was called the derivative suggestion box, and then it turned into integral suggestion box.
Okay.
But it was essentially once we learned it was as we were learning derivative rules, they then would like were asked to just like make their own problem. I mean, it was really so that like it was because I just told them like you have infinite homework. You can make as many like you can take a derivative of any function. Like, and so, yeah, they would, make them, like, write down functions, and they would, like, I'd always write, like, tangent of x, and they'd always, like, put in, like, 9 things multiplied together, and everything's, like, nested 4 things, and like, raised some other function. Like, they're doing an entire page to take the derivative of these functions, and they'd put them in, and they'd, hand them to, like, their friends, and their friends would have to do them, and it was pretty mean. But with the integral, they started with a function. They'd take the derivative and put the derivative in. So it was actually going to be integrable because
Yeah.
that one's a little bit trickier.
That's hard,
But it was again like then they could trade with a friend and they know that this has a solution out there.
That's great.
What you used to do on tests. We should make a project like this too. But one of my test problems, I would just give them an integral. Then part A, write a clear area problem that has this integral as the answer,
Like that,
then a volume problem, then a work problem. So there are 3 parts, and they have to do all those. But they struggled because I don't think people, they don't realize how carefully you have to write these problems if you want a certain answer.
I thought you were going to say, as part of your test problem, you had them take the derivative of something and then hand it to the person next to you.
That would be good too. You just continue down the road.
Yes.
What's that game where you start with a phrase and then you whisper it?
I was just thinking that.
Telephone,
It's like,
yeah.
So the one at the end has to give it back to the one at the beginning. It's just like, here's your problem
Derivative,
now.
integral,
Derivative, integral.
Yeah,
right.
You see
I
how
love
far
that.
the solution goes.
I love it. You should.
Okay,
That's
during this
great.
session, we've come up with smelly stickers and this excellent practice of derivatives.
I
and
do
integrals.
love that for
Yeah.
a smaller group session.
Yeah.
Yeah, I think that would be.
I would definitely do that. Oh, those lucky students.
That's so good.
It'd be fun.
There was one time I taught pre-calc, and I tried to do an activity where we were in the rational roots test. So then I had them break into teams and construct like 3rd or 4th degree polynomials, and then it was kind of like Battleship. You had to find the zeros of the other people's
Oh, I love
polynomials.
that. I love that.
Would they if they asked the team for this, would they just tell them it's positive or negative so they could start honing in on where the 0 was? Or...
I think I made them keep them integers at least, but
Okay.
it was just do the test and then you get a finite list and then just go.
That's a nice idea.
I like it too.
Oh yeah, that would be a good way of kind of reverse engineering a problem.
Mhm.
Is that you just take the factors, multiply them out,
That's right. Yeah.
find the
So we have so many wonderful suggestions, which is great. One other thing I know that I constantly run up against here, and I'm trying to figure out how to view, productively, is how do you implement some of these things within the current constraints of what the autonomy that you have or don't have in the classroom. Because ultimately we want this to be helpful, and I know that I do a lot of storing things out for, when I have my own classroom, I'll do X, Y, Z, but I mean, we also want to, I think we really want to work on ways for how we can do better right now as well. And I didn't know that's something that I come up blank on often.
I mean, is there any autonomy in the classroom with the calc, recitations right now?
Not really.
Yeah.
Not really. I mean, things like what Joel was saying about having his students even talk with each other for 5 minutes about the problems before talking about with the TA, I think that's excellent. And I think that's a perfect example of a small thing that you can do that does have an impact, but it's tricky.
definitely think there's like pedagogical ideologies that you can take into the classroom, right? Things that like your beliefs and these are the ways that things should happen, and that does have an impact of how you come across as a teacher. But then also finding this is the framework in which I have to work in, and these are the reasons why that framework is actually helpful in these certain ways, and then trying to find how can I then fit within there. Even if you don't entirely agree with it, saying these are the pros and cons to it, how can I accentuate those pros and kind of take back the things that you believe are cons.
Yeah, so if any of you guys during the weeks even accumulate any more of those little ideas like that are significant of how you sort of work within that, I would love to hear them for one. I'm sure other people would as well.
Well, one thing that comes to mind on this topic is, okay, fine, it doesn't help during the regular sessions, but in the summer, grad students get to teach their own courses.
Yes.
Typically how that is presented to them is, here's the course you're teaching, here's the book, get the syllabus from someone, there you go. That's not really a lot of guidance in terms of coming up with a thoughtful classroom strategy or anything. But I don't, obviously there's not any resources for the department to suddenly be like, and we're going to have a week-long workshop before session 1 starts.
Well, could you request something like that through the?
I guess we could talk to the ESO people.
I think that'd be really helpful with if we continue doing the projects in the calc sequence. I think a lot of people would really enjoy having some kind of workshop at the beginning of it, of how to have more of an interactive classroom. Because I know I've talked to a lot of people and they've said that things aren't going super well, and then I ask them, how do you feel about it? And they're like, oh, I don't really know what to do. Well, yeah.
Wish those people would come ask for help.
Yeah, I know. But they won't.
I know.
I found putting students in groups the first time in class very intimidating. That was hard to do.
I thought it was easier when I did it last spring because Mary was implementing a similar thing and was like, oh, here's an idea for this checklist you can give your students of fun facts about them that they will totally like filling out, that lets you put them into reasonably evened out teams, which I suspect she might have gotten this idea from TBL stuff, from having done that the prior semester. So some people probably don't know that you can do things like that.
I have a question. So, and I know we're over time too. So yeah, if anyone needs to come out. So, for instance, this seminar is something that's meant to help support grad students as they're teaching. But as I look around here, I'm very happy with all the faces that I see. But everyone here has pretty significant teaching experience and background and knowledge. How do you pull people who do not necessarily?
You get mandatory. No,
Yeah. But that's like an even harder question than how do you get all of the graduate students to engage socially with each other, which is already something that we're not good at resolving. Well, it's just I don't know. For example, international students have a hard time socializing with people, and I suspect they also are among those who run into more difficulties finding support when they're teaching their first standalone in the summer or whatever, when they are just told, okay, here's the thing, do it. So I don't know what I'm supposed to do about that, but
I don't know, because it's kind of at least when I first started here doing recitations, it was okay, nothing's on fire, so it's all fine, right? Even though I wasn't happy with it. And I mean, especially I think now with even I think if I had what they were doing in Calgary right now, I would have just been this is fine. I don't need to try. I don't need to try it all. I don't need to really prep that much, which I think is a lot of the point.
Yeah.
But I think it takes a lot of the edge off of I want to do something different.
There's little desire to excel.
Yeah, and then it was then the summer came and it just felt there was all of a sudden no resources.
Yes. Thank you.
Thank you,
everybody.
everyone.